Hello everyone. Today I just wanted to show you how to navigate the expression tables, how to download the files from your RNA-seq pipeline, and then how to use those files to normalize them and then run factor regression analysis. So let's take a look. This should be your pipeline. So you probably ran something like RSEM, or maybe you did differential gene expression, and then this is your output file. So you have your d-seq files, and you can download the zip file, and then inside you will see the d-seq files that you can look at fold change and the p-values. And then over here you have expression genes FPKM. Now that is the table that you want to use. You can use this table for principal component analysis, you can use it for normalization, you can use it for other machine learning methods, and you can also use it for the factor regression analysis. Now before you go on, you actually have to normalize the table. So here's my normalization table. You actually do start quantile normalization and end just the same way as you did it for PCA. So remember that after quantile normalization you can also do PCA in this utilities section, and then you will get this kind of a file. Again, make sure that this is a TXT file, and this is gene expression values in FPKM. So what does this table look like? So this table actually looks like this. This table will have a gene ID, again the same way that we looked at the expression genes, and then it has values inside. But your table is going to have a lot more samples over here because we started off with a bunch of samples from all the breast cancer files. But to do factor regression analysis, we're going to do something different. We're actually going to select those samples that have two types of cancer, estrogen receptor positive and triple negative, and two types of mice, NOD and anthemic nude. So these are the two mice types that we can compare, and the two cancer types that we can compare in terms of factor relationship and in terms of interaction of factors. So this table is going to be available in the lesson. You can download it as well, or you can just take your expression table and then you can you can delete the files that are not fitting this description. Now, how did I select these specific samples? Let's take a look. So in the supplementary files that come with the publication, there is this description for each one of the runs, what type of a mouse. So you can see that there's XID, NOD, SCID, gamma, anthemic nude, etc. And then if we want to take the ones that we can compare, we can get rid of this one and this one and this one, or sorry, leave this one. So we will have a smaller number of samples. And then over here we have hormone status, so we have ER positive and triple negative. So how do we select samples? So we list all of our samples that have the same combinations. And then we'll just select two of each combination. So we will have 4 pairs. 4 times 2 is going to be 8, so 8 samples. And here's the ones that we selected. So triple negative SCID, triple negative SCID, triple negative anthemic nude, triple negative anthemic nude, and then ER anthemic nude, ER anthemic nude, and ER SCID, ER SCID. So these are the ones that we selected. So there's going to be 8 files. So let's take a look at our table. There's 1, 2, 3, 4, 5, 6, 7, 8 files. And what I did was I deleted all the long names that we had with the group 1 and group 2, because a long name is actually going to break the algorithm. It only reads so many characters. So we shortened the name, and now we have a clear indication over here for what the file name is and then what group it should belong to. Okay, so now we can go back and we can go to areas of analysis, and this is now how to run factor regression analysis, right? So we can go to supervised analysis. Why supervised? Because we know what we already annotated these samples. So that's based on annotation, so therefore it's supervised. Now we can do start, and then we can select factor regression analysis. Now after you do that, you get this little pop-up, and you can create how many factors and how many levels within each factor we are going to work with. So we have two factors, mouse type and cancer type, right? So we will add one. And how many levels within each one? We have two. So we have ER positive and triple negative. That's two factors for cancer, so we'll type 2. And how many mice do we have? We have two types of mice, nod and anthemic nude. So let's put 2 over here as well, and let's do next. Now we can add our file. So now I have prepared this in a TXT format. Now you can notice that I did 2. I have the original one, and then I also ran quantile normalization with threshold of 5. So I'm going to upload this, so you see 100%, check, and now I have, so let's take a look at what we have. ER, nod, ER anthemic nude, triple negative nod, triple negative anthemic nude, triple negative anthemic nude. So how am I going to separate this? So what is A1? A1 is going to be ER nod. So I'm going to put, okay, sorry, A1 is ER, B1 is nod. So I'm going to put these two here. What is A1, B2? A1 is ER nod, or ER. ER is our first factor is cancer type, and number 1 is ER, but second factor for the type of mouse. So that is going to be anthemic nude. So I'm going to put this one, and the same thing for the second type of cancer, triple negative. I'm going to put triple negative, so you can see that nod is here, ER, triple negative, and then anthemic nude. That's it. Now I go continue, end. Okay, and now I'm going to save my pipeline and give it a name that I can remember what I'm doing. So what did I do? I took PDX, and then I quintile normalized it, and then I'm doing factor analysis. Okay, and I'm going to save this, run my pipeline, and make sure that you run the pipeline and you see that it started. Okay, and what you will see is these are actually quite fast pipelines, so it's not going to take a long time. But I'm going to just show you the output that I already have. So this is what it's going to look like. Okay, and this is what the output will look like after factor regression analysis. So again, we do have the gene ID, and then over here in each one of these columns you will see what the file name was. So up until over here, this is exactly the same. And then here you have the factor analysis results, so these columns. So this is t-test, f-test, for the combinations of samples, of factors and levels. And the rest of this you can follow through the Transcriptomics 2 lesson to work with this table, and I will prepare another video so that we can also review that just like this.